Hello, this is Mrs. Chow, and for today's lesson for algebra, we are going to be covering lesson 1.08 on problem solving. Our objectives for today, these are our goals that we're going to be covering in today's lesson. First is to represent mathematical situations as equations using variables for the unknown. Number 2, represent real-world situations as equations using variables for the unknown. Number 3, apply the 5-step problem-solving plan to solve real-world problems. And lastly, define appropriate quantities for the purpose of descriptive modeling. So what we're going to be doing now is we're going to be taking what we've learned thus far in Unit 1 and we are going to problem solve. And honestly, it's not as confusing as you think when you have a question. Sometimes I know when we're working with word problems, we can look at a word problem and go, ah! Once we are going to take our 5-step problem solving plan and help us with setting up, identifying, and helping us solve those problems. This is the 5-step problem solving plan. So the first thing you want to know is you want to identify. You want to identify the knowns and the unknowns. So the knowns, that's what's given to you. The unknown, that's what we don't know yet, and that's what we're going to be asked to do. Once we identify those things, step 2 is to strategize. What skills do you have that can help do what you are being asked to do? Set up variables and draw pictures if applicable. So remember, variables, those are a letter that represent a number. So our variables are going to be, we're going to use variables to help us with our unknowns, to help us solve for our unknowns. Step number 3, once we have identified and strategized, we can set up, reread the problem, and use our strategy to write an equation that represents the relationships. Step number 4 is we're going to solve. So solve the equation that we wrote and write the answer in a complete sentence. And step number 5 is to check. Does our answer make sense? We can go back and recheck our math. We can look at the problem and make sure, does our answer make sense? Let's go ahead and get into our light quiz questions. So for light quiz question number 1, it says there are 8 more girls than boys in a class. There are 29 students in all. We're going to let G represent the number of girls, and we need to write an expression to represent the number of boys. So we need to think of it in terms of how many boys there are in the class. So let's think of this first sentence here. It says, there are 8 more girls than boys in the class. So if I were to write that out, there are 8 more girls than boys. Let's think of it in terms of this way. What if I said there are 8 blank boys than girls? If there are 8 more girls than boys, if we switch it around, there are 8 less boys than girls. It changes it a little bit. Since we're switching it, there are 8 more girls than boys, which is how the problem gives it to you, but we need it in terms of boys. So if we think of it that way, there are 8 less boys than girls. And what this is saying is this is telling us that we take the number the number of boys is equal to the number of girls minus 8, because there's 8 less than there are girls. So that's going to be C. Moving on to light quiz question number 2, it says a problem states there are 4 more kids in a pool than adults, and there are 20 total people in a pool. How many kids are there in the pool? And they tell us to let K represent the number of kids. So if we think about this, we know that there's kids in the pool, and we know that there's adults in the pool. We also know that the total number of kids, so if we take the number of kids and we add it to the number of adults, that's going to get us the total amount of people in the pool. And they told us the total is 20, so we know it's going to equal 20. Now down here is where it says let K represent the number of kids. So kids is going to be equal to K. And what this means is that we need it in terms of kids. We're going to think of everything in terms of kids. So now if we go to the adults, we have to think about how they gave it to us for the adults. Going back to light quiz question number 1, they did the same thing here. Notice how they said there's 4 more kids in a pool than adults. So to get the number of kids, we would just take the adults and add 4. But now we need to think of it in terms of adults because we need everything to be represented using the letter K. So if there are 10 kids, to get the number of adults, we would subtract 4. So let's say there's 10 kids in a pool. To get the number of adults, we would subtract 4 and get 6. So instead of adding 4, like what we want to do, since it says 4 more kids, we're going to take the number of kids and subtract 4. So now if we go down to here and we take what we created, K and K minus 4, and plug it in for the kids and the adults, what we have is K plus K minus 4 is equal to 20. And now what we need to do is we need to combine like terms, and we can add, we have 1K plus 1K. So now we have 2K minus 4 equals 20. Therefore, our solution is D. So be careful with this because they're giving it to us in terms of like if we were given A for adults instead of K. So you have to do the opposite of what's given to us in this problem. Moving on to like quiz question number 3, it says write an equation to model the given situation and then solve for the width. The area of a rectangle is 64 centimeters squared. The length L of the rectangle is 12 centimeters longer than the width. So we need to find the width. That is our unknown here. So as soon as we see something like the area of a rectangle, we want to draw a rectangle. So if we draw the rectangle and it tells us that the area is 64 centimeters squared. So everything that's covered within that rectangle is 64 centimeters squared. Then we'll have like the width of the rectangle and we have the length. So the width will use W. They told us the width is W, and the length will use L. So now let's think about how do we find the area of a rectangle. So there's a formula for that. To find the area of a rectangle, we simply multiply that length times the width. So we would take L, multiply it times W, and that's going to give us 64. So we know that our area is 64, and it's just the length times the width. So now let's look at what else we're given. In this last sentence here, it says the length of the rectangle, so our length is 12 centimeters longer or 12 centimeters more than the width. So our length is, and is the same word as equal, 12 centimeters longer than the width, or the width plus 12. Or you could do 12 plus W. Either or, W plus 12 or 12 plus W. So now what we did here is we created this problem. So now we're thinking of, we have the width, and we think of the length in terms of the width. So now instead of thinking of L, we're going to think of W plus 12 as our L. If we go to our formula for area and plug in what we know, so we have 64 is equal to our length, L, which now we're going to think of as L as W plus 12 times our width. So remember, instead of putting the L, we're putting W plus 12. We're going to learn how to solve this particular problem later. But for now, what we can do, since it is multiple choice, is we're going to, and we talked about this earlier in Unit 1, we can plug in our multiple choices to see which one fits. So we're going to just go through A, B, C, and D, and we're going to figure out when we plug in each of those values, which one makes our statement true. So we're going to be plugging in each of those into here for W, because remember we're needing to solve for W. So if we first do A, and we're going to plug in 12. So 64 is equal to 12 plus 12 times 12. So W is 12. That gives us, is 64 equal to 24 times 12? If we multiply now 24 times 12, we get 288. And 64 is not equal to 288, so therefore it cannot be A. So let's go ahead and let's look at B here. So now we're going to plug in 8. Is 64 equal to 8 plus 12 times 8? Oh, we don't need that extra little parenthesis there. Okay. Is 64 equal to 8 plus 12? So 20 times 8. Oh, I did it again. I added in that parenthesis. Is 64 equal to 20 times 8 is 160, which those are not equal, so it cannot be B. All right, let's hope it's C. So now we're going to plug in 4 for W. 64 equal to 4 plus 12 times 4. 64 equal to 4 plus 12 is 16 times 4. 16 times 4 is 64. So it looks like that one works. So it looks like C is our solution. Just to double check, let's plug in D real quick and just see, but I'm pretty sure we're good with C. is 64 equal to 16 plus 12 times 16. So 16 plus 12 gives us 28. And then we have 28 times 16, and that's going to give us a very big number, 448, which is not 64. So we were right. So C is the correct solution. All right, number 4. We need to solve the given problem. Perfect adult golden retriever Speeda is 4 years older than twice rambunctious puppy Scout's age. Scout is 2 years old. How old is Speeda? So what we want to do here is let's first assign a variable for Speeda and Scout. So let's say that Speeda is x. So we're just giving Speeda the variable x. And Scout, let's say, is y. So Scout is y. So I just made those up. Those are very typical variables that you use for math, x and y. So those are the most common ones that when you need to think of a variable or replace something with a variable, we use x and y. Okay, so now let's go through here. It says that Speeda, or now we're thinking of Speeda in terms of x, is, so Speeda is, remember how I said earlier? So x is, wherever we see the word is, that means equals. So x is 4 years older. So if we think of 4 years older, we're thinking of 4 years like more than. So we're going to be adding 4. 4 plus, and then it says twice. Twice means 2 times our rambunctious puppy Scout, or 2y. So x is equal to 4 plus 2y. Speeda is 4 years older, so adding 4, then twice or 2 times Scout. So x is equal to 4 plus 2y. And they told us in the second to last sentence that Scout, or y, is 2 years old. So we know that y is 2. So now we can plug in 2 for y. So we have 4 plus 2 times 2, making sure we follow orders of operations. So we have to do multiplication first. 2 plus 2 is 4, or 2 times 2 is 4. And now we have x is equal to 4 plus 4, or 8. So x, which remember x is Speeda, is 8 years old. So now let's think about it. Let's go back and check, go back to the original problem and see, does this make sense? So if Speeda is 8 years old, Speeda is 4 years older than twice Scout's age. So if Scout is 2, if we multiply that by 2, because it's twice, we're going to get 4, and then add 4 to get Speeda's age. So 4 plus 4 gives us 8. So therefore, it looks like we're good. We checked it. Speeda is 8 years old. And let's go ahead and finish up with our last example with like quiz question number 5. We need to solve the given problem, and the problem states that a rectangle has an area of 104 centimeters. So as soon as we see that, we can draw our rectangle. We know that the area is 104 centimeters squared, and we know how to find the area of a rectangle. Remember, it's the width times the length. And then the next sentence tells us that the width of the rectangle is 26 centimeters. Oh, so instead of writing W here, we can put in the actual width, which is 26. What is the perimeter of the rectangle? So all the information that's given to us is given to us in terms of area. And we know the area of a rectangle is the length times the width. They're asking us, however, to find the perimeter of the rectangle. So we only know the width. We don't know the length. Therefore, we need to first find the length to help us find the perimeter. And remember, the formula for perimeter is 2 times the length plus 2 times the width. So let's first use what we're given. We're given the area of that rectangle, and we know the area is length times width. We also know the area is 104 centimeters. We don't know the length, so we'll keep that as L, but we know that the width is 26 centimeters. So what we want to do is we need to rearrange this, and we need to solve for the width. So if we're multiplying the length times the width, we need to think of the opposite of multiplication. So what is the opposite of multiplication? If you're thinking division, then you are correct. So to get the length by itself, what we're going to do is we're going to divide the area by 26. When we divide 104 by 26, we're going to get 4. So the length is 4. So now we know the length, we know L is 4, and we know the width, remember the width is 26, so we already know the length and the width. Now that we know them, we can plug them into our perimeter formula to find that perimeter. So P is equal to 2 times our length, which our length was 4, plus 2 times our width, and our width is 26. Now we have everything plugged in, so we can just simplify to find our perimeter. We first need to multiply. Don't forget about orders of operations, PEMDAS. So in here, in our problem, we have multiplication and we have addition. So we need to do all the multiplication first. 2 times 4 gives us 8, and then we're going to add it to 2 times 26, which is 52. Now we can just add 8 plus 52 gives us 60. Therefore, the perimeter is 60 centimeters, or we can just say 60. Now, make sure you do the lesson practice problems on your own. If you go to lesson 1.08 and you click on practice, there are a ton of practice problems in there to help you. This is giving you extra practice. These are meant to help you before you take your quiz. So check your solutions. If most of them are correct when you're doing the practice problems, then go take the quiz. If many are incorrect, review, practice some more, and then take the quiz. So you can review, you can rewatch the recording, you can go through the online lesson on your own, get some more practice, and then take that quiz. Remember, you get 3 chances and only 3 chances to take the quiz. If you get a 0, 1, or 2, 1, 2, or 3, check what you missed, review why you missed it, then retake. Otherwise, have a fantastic, fantastic day, and we will see you next time.